Welcome to tutorial 3.6 part 3 on stoichiometry. This is the last of the tutorials in section 3.6. So let's have a look and see what these are about. In the first two tutorials we converted first from moles to moles in a balanced chemical equation. And we also then included going from moles to grams. And all we want to do now is complete it by also starting with grams and ending with grams. So that's the only difference. We're going to start with grams and end with grams rather than starting with moles and ending either with grams or moles. We're going to go through 3 examples. Here's the first example. We have 18 grams of hydrogen that are burned. And the question is, what is the mass of water that we will be able to produce if all 18 grams can react? Well, the equation tells us that 2 hydrogens will produce 2 waters, so therefore we have to figure out how many hydrogens we have in 18 grams. We do that by looking at the molar mass. We notice that H2 has 2 grams per mole, so therefore if I divide 18 by 2, I know that I have 9 moles. We think of them as 9 boxes of hydrogen. Here's the math worked out nice and explicit. 18 grams at every 1 mole has 2 grams. We have 9 moles of hydrogen. The next step is to figure out how many moles of water we're going to be able to make with the 9. Well, it's a 1-to-1 ratio, 2-to-2 ratio being the same. We don't have to think about that very much, so for every 9 we're going to make 9 moles of water. The last step is to figure out what they're going to weigh. Well, water weighs, it has 2 hydrogens at 1 gram per mole, 1 oxygen at 16 grams per mole, so 18 grams per mole is the molar mass of water. So we simply multiply the 9 moles that we say we could make times 18 to get 162 grams. And here it is explicitly written out. 9 moles times 18 grams per mole gives us 162 grams of water. Alright, so that's it. That's our first example. Let's look at example number 2. The ratio is a little bit harder to look at, 3 to 1 to 2, but apart from that, it's exactly the same process. What we're going to do first, we're given a certain number of grams of one of the reactants, in this case, of hydrogen. Same as before, divide by the 2 grams per mole. How many moles do we have? 8. Now this ratio is a little bit more complicated. It's not 2 to 2 like last example, but a 3 to 2 ratio. So what do we have to do? We have to multiply 8 by 2/3. So we multiply it out for every 16. Oops, this is the first step. I jumped ahead of myself. 16 grams divided by 2 grams per mole gives us the 8. Now in this last step, multiply the 8 moles by 2/3. So what do we get? 5.3 moles of ammonia can be made from 8 moles of hydrogen. The last step is to figure out what those weigh. What is the mass of those 5.3 moles? Well, we'll just multiply by the molar mass of ammonia. What is the molar mass? 14 plus 3 is 17 grams per mole. So therefore we multiply the 5.3 times 17 to get our final answer of 91 grams. Okay, I hope that felt pretty good. You notice they follow exactly the same pattern every time. Last example, just to do one where the ratio is a little bit more cumbersome. 160 grams of oxygen are present. What are we going to do to figure out how many grams of carbon dioxide can be formed in this particular reaction with oxygen and butane? Start the same way. Divide the 160 by 32 grams per mole for oxygen. It turns out we have 5 moles of oxygen that were used up. The ratio this time is a little cumbersome. It's 8 to 13, so we have to multiply that out again after we find out the math, how to get to 5 moles of oxygen. So if we multiply 5 by 8 over 13, we get 3.1 moles of carbon dioxide will be formed. Last question, what do those 3.1 moles weigh? Just literally imagine 3 boxes and a tenth of a box sitting there of carbon dioxide. Each box has a mass of 44 grams. We get that by adding 12 for the carbon plus 2 times 16 for the oxygens at 44 grams per mole or per box. And therefore we can make 135 grams of carbon dioxide. That's it. I hope that felt pretty good. It's obviously very much kind of a rote thing you can do each time. It's always the same. But stop and think about each step along the way so you're not just doing it mechanically. But it's also nice to have a table and do it somewhat from muscle memory so you don't have to you'll feel insecure about it at all. All right, that's good. We'll practice again in class as always. Thanks. Bye.